Good morning, students. Today we are going to learn the exercise part in chapter 12 electricity. So, we are going to do at least 3 problems a day so that we can complete this exercise part, and we'll do the important questions first. So, I'm going to take the question number 6, 7, and 8 in your book. If you have a book, turn to page number 221, exercise. Okay, now I have written this question here. So let's read this question. The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistors are given below. So there is a current which is flowing in a resistor. Okay, so and they have given the potential difference also. So for 0.5 amperes of current, it shows 1.6 volts of difference, potential difference, and here for 1.1 ampere it shows 3.4. So like that they have given some resistor. There are potential differences which is given here. So what you are asked to do is you should plot a graph between V and I, and also you should calculate the resistance of that resistor. Okay, let's try to do how this can be solved. Okay, let's plot a graph between volt and current. Okay, so we plot a graph like this. So this is volt and this is a current. So for current it is I, and for potential difference volt, right? For current it is shown in an ampere, right? So here other points are given, you have to put it here. I'm going to take volt 0.6, so we'll start with 2, 4, 6, 8, 10, 12, 13 and 14. And for current I will write as 1, 2, 3 and 4. Clear? Okay, now try to put it all these in this graph. For old it shows 1.6 and 0.5 current shown here. For 1.6, so 0 is here, so 1 comes here, so 1.6 will be somehow here. And for 0.5, this is 0.5, so I just want to put it here. So this is our first point. And for 3.4, 1, 3.4 comes here somehow, and 1 will be here, right? 1 will be here. And for 6.7 it is 2, 6.7 will be coming here around, and for 2 it will be here, so put it here. And for 3, 10.2, 3, so around here. And for 13.2 it's 4, around here. So what we are going to do is we're going to connect all these lines, right? Alright, so after connecting it, it shows this is the graph we have plotted between V and I. Okay, so to find the resistance of the resistor, let us assume any of these points. We have 1, 2, 3, 4, 5 points. Let us assume any of the points. So let us take this point. So here at this point it shows 6.2, okay, 6.7, and 2 is the current. So we will write like this. Clear? For 6.7 it's 2. So this is what the resistance of the resistors. I'm going to take only this point. Even if you want to take this also you can take. That means 13.24, this also you want to take. If you want to take, you can take, that's not a problem. So assume any one of these points. So what I'm going to do with this, so let's take Ohm's law. You all know what is Ohm's law. It talks V is equal to IR. So we don't want any other thing, we need only the resistance of the resistor. So R is equal to V by I. We know what is V and also we know what is I. So V, here we have taken V is equal to, what is V here? It is 6.7. And what is I? It is 2. Clear? So put it all in this formula. So it gets 6.7 divided by 2, 3.3 ohms. So this is the resistance of the resistor for this particular point. Even if you want to do with this, you can try by yourself. Clear? So this is our first question. This is our 7th question. Clear? I hope you will understand this. Let's move on to the next question. Our next question is 8th question, which is given in your book. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in a circuit. Find the value of the resistance of the resistor. So it's battery, it is connected with a battery of 12 volt. So volt is equal to 12 volt. Okay. And current also given in your question, and you need to find the resistance of the resistor. So current I is equal to 2.5 milliamp. So if you can check this in your book in page number 200, they've shown that. I just want to show that in your book. Turn to page 200 in your book. It shows that 1 milliampere is equal to 10 to the power of minus 3 ampere, right? So milliampere is equal to 10 to the power of minus 3 ampere. So we can write this as 2.5 into 10 to the power of minus 3 amp, right? Milliampere can be written as ampere because it shows in the current. So we'll write it like this. Let's write and what is resistance, that we don't know. So let's go to the Ohm's law again. V is equal to IR. You should not forget this formula, it's very, very important. V is equal to IR, but we need only R, so we can write it as V by I. What is V? It is 12 volt. And what is I? It's 2.5 into 10 to the power of minus 3 ampere. If you do this, you will get 4.8 into 10 to the power of minus 3 ohms. Clear? So this is how we have done this formula. This is how we should do. You check that what is asked actually in your question. So and what is actually given in your question, and then put it all in a formula what is asked. Clear? So for today, and we have done only 3 equations, 3 exercise questions, and the remaining we'll do it in the next class. Thank you, student. Let's move on to the next question. Question number 6 in your book. Okay, we'll read that question first. A copper wire has a diameter of 0.3 millimeter and resistivity of 1.6 into 10 to the power of minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Actually, 2 questions they asked here. One is the copper wire has a diameter. So this is a copper wire. If you think is a wire actually, the wire, and I've drawn this part, okay, little big one. The diameter of that copper wire is 0.5 millimeter, okay, and the resistivity is also given. The resistivity is 1.6. What will be the length of the wire? So they didn't tell us what is the length of that wire to make it resistant 10 ohm. So resistance also given, and they are asking what will be the length of the wire, and also how much does the resistance change if the diameter is doubled, and if this diameter is doubled, if it doubles, then what is its resistance. So we should do two things here. One is we should find the length of that wire, and also after finding that, we have to find the what happens to the resistance if the diameter is doubled. Okay, let's write what are the things is given in this question. First is they have given diameter of the wire is 0.5 millimeter. So if it is a diameter, then we can try to write its area. Area is equal to, you know the formula of area, it's pi r square. But in this formula we do little one small modification in this formula. So instead of r is nothing but the radius is only this much, right? But they have given the diameter, the full. So we'll write like this: pi r d by 2. That means diameters of is actually radius. Diameter का आधा तो radius है ना, so we write d by 2 the whole square. Can you understand this? So it is pi r square. I've just made a small modification here in this formula. Instead of r, we write it as d by 2, because diameter is the complete one, so, but radius is the half of it. So we write d by 2, and then the resistivity is also given in your book. The resistivity is also given in the question, and resistivity will be written as rho. It is 1.6 into 10 to the power of minus 8 ohm meter. And then we have given length is not given. Resistance is also given in your question, it is 10 ohm. So we have first we do try to find the length of that. So first we do find the length. So we should use the formula r is equal to, and we all know the formula, rho L by A. But r is also there, rho is also here, and area is also here, but we don't know what is the length. So try to put length in one side and keep all these at the other side. Then A will go on the top, so r will be already there, and rho. So this comes the formula. Clear? So we substitute all these things in that formula. What are the things which is given here in the question? You put it all in the formula. So R is here 10 ohms, and area we know that it is pi d by 2 the whole square. So d by 2, that means d is the diameter which is given here. D by 2 is 0.5 divided by 2. So if I 0.5 divided by becomes 0.25 into 10 to the power of minus 3. Yeah, so we write it directly here in the formula. So it's 0.25 into 10 to the power of minus 3. Sorry, it's 10. Resistance is 10, and pi, first we have to write pi value is 3.14 into 0.25 the thing d's into 10 to the power of minus 3 the whole square, divided by rho. Rho is given in your question, so it's 1.6 into 10 to the power of minus 8 ohm meter. This is actually ohm. Right. And then if you calculate this, we'll get the answer as 122.72 meter. So length we have find. And in other case, so we just find the length. Okay, this is over. And then what they are asking, another thing, how much does the resistance change if the diameter is doubled? If this diameter is doubled, it means doubled, so we should find the complete thing. The double means it become 2, right? So not 1D, it become 2D. Clear? So we write it here, resistance we should find, and the D, so we write the another one, so I write it as D dash is equal to, it's 2D. 2D is nothing but 1D we already know, it's 0.5, so 2 into 0.5 millimeter, so it can be written as 1 millimeter, because half 2 of 1 over here, so it can be written as 10 to the power of minus 3 meter. Clear? So now we put it all in the formula. So now we know the formula, same formula we are going to write it again, r dash, so instead of the other one, so we write r dash is equal to rho L by A, right? So then we put it all in the formula. Rho, we know the formula, 1.6 into 10 to the power of minus 8 into L, length just now we find, what is this L, 122.72, and then we have area is pi d by 2 the whole square. Okay, so we'll continue here. So it's 1.6 10 to the power of minus 8 into 122.72 0.72, and then divided by, so we know the pi formula, it's 1.34, 3.14 into the value of D just now we find, it is 10 to the power of minus 3, so I am writing it as 10 to the power of minus 3 the whole square. So this 2, because of square, it become 4, so that goes on the top, right? So if I put all these values and then calculate it, I'll be getting 2.5 ohms. And this happens, this is what the resistance if the diameter it becomes doubled. If it becomes doubled, then the resistance will shows 2.5 ohms. Let's see it once again. This is the question, and we put all these things. First of all, we find what is the length of the wire by using all the values which is given in this question. Then after finding the length of the wire, then we started finding the resistance of the wire. That means it shows if it doubles, if it becomes double, what is the resistance. If the diameter of the wire is becoming doubled, then what will be the resistance. Clear? So this is how we should do this formula. You do this example.